every 10 years we have get this problem because of coronavirus family, and I will try to give some details about the new coronavirus family. The coronavirus family is the SARS-CoV-2 is the member of coronavirus family, and is a member of coronavirus family and the order of Neurolovides. And the coronavirus family consists of 4 genera, namely genera alpha, beta, gamma, and delta. Alpha and beta genera infect human and affect directly respiratory, gastrointestinal, and central nervous system. And Dr. well encapsulated and supported with various articles about it, affects the multi-organ failure. And I think that's the reason of the deaths are responsible for multi-organ failure. However, the others, gamma and delta, infect the birds. So we can expect that our new novel virus is a member of alpha or beta genera. And I will detail it the next slide. The new virus SARS-CoV-2 is a member of beta family, and there are some relationship. There are some resemblance between the SARS-CoV-2 and SARS-CoV-2, and you know that they direct effect around the world. But I think SARS-CoV-2 is more dangerous than others, in my opinion. But we just see. And SARS-CoV-2 is I said that is a member of beta genera, and originated from Wuhan city in China. And next general host may be the rhinolophus affinitis spread from Wuhan city in China, because of the similarity between the over 19.5%. But one virus isolated from the pangolins, and the genomic sequence was analyzed, and a similarity between the pangolins is the one isolated from the virus from pangolins is similar between nearly the 100, and maybe the intermediate host could be the pangolins. But more, in my opinion, more studies should be investigated to more reliable data. And although in the previous presentations you listened that S protein is the main protein of coronavirus family because of entering their host, and I will give some details about the S protein. S protein is the transmembrane protein, and the structure of the S protein is here, and I gave it from the protein data bank. And this transmembrane protein located on viral surface and has trimetric structure, and consists of 2 units, S1 and S2 units. As you can see this figure, S and ST units are the attachment units of on their host, and a SP region consists of 2 other regions, entity and C regions. And entity, north transmain domain, and C regions are capable of receptor binding domain. And in the middle site, cleavage site is the main. In my opinion, it's the main side of this virus, because it is cleavage site, and before the entering of the body or on their host, the S protein could be activated from this cleavage site by the host of some enzymes, including trypsin and chemotrypsin. I will give some details. And the cleavage site is important, you know that. And the SK domain and S2 domain, is the attachment units on their host. But how to enter the SARS-CoV-2 on their host? Two entrance way of the coronavirus enter the body. First one is human antigen converting enzyme named HACE2, and the other is human dipeptyl peptidase enzyme. But the novel virus, which one? The novel virus could be used to which one? I will give the details with reported articles published from Nature Communication. First of all, how to activate the S protein? I will say that the first key issue is the activation of S protein by the cleavage site. You saw the in this slide, you saw this. It is the main cleavage site of activation of these proteins. Firstly, the activation is S protein depends on protein cleavage activity by two steps. In the first step, S1 and S2 permanent cleavage is necessary, and the second step, activation cleavage on S2 site. And the cleavage of S protein is related with the protease enzymes of the host or cells. Enzymes like trypsin, furin trypsin, or catepsins. After that, when the activation of the proteins, how to enter their host, the researchers published in Nature Communication, and I added the reference page with reference to when the HAK293 and HICA cells were used, the new SARS-CoV-2 virus mainly enters these cells via endostosis with the help of the phenylenediol 3-phosphate 5 kinase and 2-pore channel type 2. And if you want to if you are interested in the transmission of the virus, you can detailly examine the reference tree. And as a result, endostosis is the main entrance way of this coronavirus. And in summary, effects of some inhibitors of SARS entry. And this slide, I will show that because if you develop some drug delivery or some biosensing systems, you can detailedly examine this slide, because from the transmission of or entrance the body of this virus is dependent on protease activation, and it's a key step for entering SARS-CoV-2. And catepsins and endostosis are the other entrance mechanism of our body, like the other virus SARS-CoV-2 and MERS-CoV. And if we use inhibitors, maybe we can block the entry of this virus by blocking the gene sequence, or develop some drugs. And the researchers use catepsin L inhibitor, and which decrease the entrance of SARS-CoV-2 into 293 HAE2 cells. And maybe it is unhelpful to develop the effective drug. And maybe we can find in a short time or discover a new drug and new vaccines. We just wait to see that. And the article which I used which was used during my presentation was published in Nature Communications, and I think, in my opinion, you should have to examine it a bit carefully. And thank you, because I don't want to lose your time a lot. If any questions, you can ask or send email from my email. Thank you.